All right, turn to page 193. Here's the warm-up for today. The key thing that you need to do on the warm-up is you need to remember that distance is equal to rate times time. And if we put that into a stop sign, well, not a stop sign, but a circle, we draw a line up here and we put D up here and then rate and time, this will pretty much solve itself. So if we want to know the time, we put our finger there and we do distance divided by rate. If we want to know the rate, we do distance divided by time. So go ahead and try the warm-up here. The distance is 10 miles, that's fixed, and we get to mess around with the different rates and times. All right, now I'm back. Let's see what we did. When it says how long, that means we want to know time. So I put a T here. We cover up. You should have done distance divided by rate. So the distance is 10, and we're going to divide by 8. We take out the calculator. 10 divided by 8 equals 1.25. So the answer is 1.25 hours, or 1 hour and 15 minutes. Because a quarter of an hour is 15 minutes. How long? If it's R, well, T would be 10 over R. And that is a rational function because you have a number over R, your variable. It's a fraction function. Now we want to know what rate. We want to know what rate so that he can finish in 45 minutes. So I want to know what rate. So we take distance and we divide it by time. Distance divided by time is rate. So we do rate, R is equal to distance divided by time. 45 minutes, it has to be in hours. So really, it's kind of tricky. You got to do 3/4 of an hour. So if you wouldn't do 45 because that'd be 45 hours. That's not what it means. It's 3/4 of an hour. So 10 divided by 3/4. So I do 10. The faster way to do that is to divide it by 0.75 instead of doing all the fractiony stuff. 3/4 is easy enough as a fraction to be 0.75. 13 1/3. So my rate needs to be 13 1/3 miles per hour. Okay. Then it says, what will their average rate be if they go T hours? So R is equal to, again, we want to know R, so it's distance divided by time, so it's going to be 10 divided by T. So again, it's a fixed distance, like between here and Wilmington is a fixed distance. It's a fixed distance of 10 miles. Next page, continuing on with the same concept here. It says write an equation that gives the time. So let me repeat this. So write this with me. So we're going to do distance, rate, and time. So what do we want to know? Rate, distance divided by time. We want to know time, distance divided by rate. So write an equation that gives his time, T in hours, as a function of the rate. So we want to know time. So we want to know time. So that's going to be distance divided by rate. So T is equal to distance divided by rate. And our distance was 10. So it's going to be 10 divided by R. Now to make it look like a function, it's based on R. So we can say T of R. So time depends upon your rate equals 10 over R. So there it has the function notation because of those parentheses there. But also T equals 10 over R would be acceptable too, because you put in a rate, and that's from the other page. Now we're going to graph it. Make a quick graph. Make a table first. We'll put rate over here and time over here. So if T was 1, 10 divided by 1 is 10. Let's go to the other extreme. If if it was 10, right, if rate was 10, 10 divided by 10 is 1. So the graph has this inverse relationship thing. 1 and 10 would be up here. 1 and 10 would be down here. So it's going to curve like so. All right. So this is rate. And then over here on this axis is time. With that inverse relationship. Slower rate, more time. Faster rate, less time. All right, what is the meaning of t of 8? Does this make sense? T of 8 would be putting 8 in here. So t would be 10 over 8. That's what we figured out on the other page, right? 10 divided by 8 is, what do we hear? An hour and 15 minutes. So time is equal to 1 hour and 15 minutes from the other page. So that means that's how long it takes, right? So it's how long at 8 miles per hour. That's what we just answered. T of 0. So it would be t is equal to 10 divided by 0. So if my rate, right, if my rate is 0, what's going to happen? What will happen if my rate is 0? Well, first of all, mathematically it's a problem because I can't divide by 0, can I? But if I have no rate, it's going to take forever to get there. I'll never get there if I have no rate. So it kind of makes sense because it's saying your rate is 0, but you'll never get there. So with a 0 rate, you don't move, right? You'll never get there. So the time would be infinite amount of time. You're just sitting there. So this is related to the graph. As the rate gets closer to 0, so as the rate gets slower, what happens to the time? So the rate gets slower, that means the time goes up. So slower rate means more time. And then the other way, as the rate gets faster, right? The rate gets faster, the time goes down. So faster rate means less time. We're not going to do this. We're not going to do that. So instead of 10 miles and a bike trip, the orange page on page 197, talks about swimming across the English Channel, right? So there's your distance divided by rate is time. So it's the same function that we were just working with, but instead of 10 up here, it's 33.3 kilometers. So again, the slower the rate, the longer the time. The faster the rate, the shorter the time. This graph is on the next page. This is a rational function. And it says, unlike the graphs of polynomial functions that look smooth and connected, the graphs of some rational functions can look like separate pieces. For example, this graph. So this graph is on the next page. So let's look at it. So we have 1 over x minus 3 equals f of x. So there it is, and it's graphed here. To type this into your calculator, you have to put a set of parentheses around here because you have to force the calculator to subtract before you divide. And we're gonna work on that throughout the whole rational function part of the class. Well, when I put a 3 there, that's an issue. So you guys have done this hundreds of times with me. 3 minus 3 is 0, right? It's a 0 of the function, but since it's a 0 on the bottom, that means I'm dividing by 0. So when you divide by 0, it creates a vertical asymptote. When you divide by 0. So when you divide by 0, you get a vertical asymptote. And that's what's happening here. So at x equals 3, that causes a division of 0, and it makes the function blow up. So the function's coming in here, and then it whoosh, blows up. And the function's coming in here, and it blows up, right? Well, down. But that's the idea, is there's a break in the function at 3. All right, now you're ready to try the purple page on page 199. So you're going to do all of these, including the ones on the back.